Leetcode 62 unique paths. It's a medium type problem and can be solved using at least two approaches. So one approach is more traditional or classic dynamic programming style, and the other one is using certain mathematical formulas. So to be precise, there is a formula how to get the number of combinations, and we already talked about it on this channel, that it's a very common theme across many Leetcode style problems and algorithmic problems when you deal with either permutations and combinations, yes? And of course, combinations are the easier version because you only have unique orders, yeah, or unique paths in this particular problem. Yeah, so if you know about those formulas, you can use them and get a much faster result or much more optimized, and otherwise you will have to rely on your dynamic programming skills if you have them. And either way, I guess it's not really very easy. That's why they classified it as medium. But even for medium, I would say it's medium when we talk about like dynamic programming and stuff like this. Yeah. So just using your normal day-to-day skills, let's say if you're just your average developer, will be hard. You need to have like some specific algorithmic knowledge in order to solve those kinds of problems. And here is the description. There is a robot on m times n grid. Yeah, usually the first, or always, the first number refers to the number of rows, and the second number refers to the number of columns. Yeah, and if it was, for example, n times n, it would mean that the grid is square. But in this case, because the letters are different, we can have a rectangular grid. Yeah, so the number of columns doesn't necessarily have to be equal to the number of rows. And there is a robot, and this robot is just a noise in this problem. It's just to create like some additional story on top of the real problem, and it's basically something located on a grid on the first cell. Is initially located at the top left corner. Yeah, so as you can see here, they drew a beautiful visualization of this problem, and the robot is here. And this is the loft top left corner. And if we talk about indices, is on the index 0 and 0. Yeah, so 0th row and 0th column. And the robot tries to move to the bottom right corner, which is index m minus 1 because we have m rows, and n minus 1 because we have n columns. Yeah, and this is the star is where it wants to go. The robot can only move either down or right at any point in time, which is the most important information out of all of this, because it of course influences our solution that we want to create here in Python in some time, once we understand the problem fully. Because, for example, if it could go both, it could jump down and right at the same time, then it would be a different kind of solution. And because it can go either down or right, it's a little bit simpler. And here is the rest, given the two integers m and n. Of course, we just have the integers. We don't have, like, this grid only exists in our imagination. Yeah, there is no list of lists of integers as usually when we deal with grids or matrices or something like this. Here we just deal with numbers, yeah, just the dimensions, and from those dimensions we should be able to construct the whole solution. Return the number of possible unique paths that the robot can take to reach the bottom right corner, and the test case are generated so that the answer will be less than or equal to 2 to the power of 2 times 10 to the power of 9. Yeah, and of course this is something which is relevant for languages like C++, because then you can choose between various types for your numbers or even for your integers, and some of them are smaller, take less memory, and some are bigger, they take more memory. So you always have to think about which one is the most appropriate one. But for Python, we cannot control this. We just create variables, and the types are handled behind the scenes. And here is an example. Let's take a look. So the robot always starts in this top left corner. Yeah, we don't have any grid as our input, just have the dimensions. And there are 28 ways in which it can reach this place. So let's try to think about it, and let's try to draw it on our own. So we have following grid. 2, 3, 4, 5, 6, and 7. And of course we have 3 rows, and that's our grid. We start here, or let me just change both background and the borders, and here we can make it blue, let's say. So how can we reach from the green cell to the blue cell? We can go, for example, like this. That's one way we can go. And the answer is 28. What is this 28 about? 28 is not about the number of steps. It's a number of ways. This counts as a whole way. And how can we diverge? We can, of course, go like this. Or go like this. So at any point, we have basically 2 options. Either way, we will have to, in total, go m minus 1 steps to the bottom, in the vertical direction, and n minus 1 steps in the horizontal direction. But we can take them in an order. So we can first use all our vertical steps, or our horizontal steps, and then our vertical, or we can mix them up, or in the opposite, first all the vertical and then all the horizontal. So basically, how many of them they are? It of course depends just on m and n. But in total, we will have to take m minus 1 steps vertically and n minus 1 steps horizontally. Which means that in total, how many steps do we have? We have n plus n minus 2. If we add them both. This is the total number of steps. And each time we can either decide when we take the horizontal steps or when we take the vertical steps. So if we want to have the unique number of paths that we already said, that would be in mathematics described as combinations. So this is the total number of possible steps, or the total number of steps that we have to take, and out of this we will choose n minus 1 or m minus 1. But in the end, it doesn't matter. I will tell you in a second that why both are equivalent. So we have this n choose k formula. Let me just draw it like this. And like this. That is supposed to be a parenthesis. Let me move it here. Okay, I'll try to make it a little bit better. Let me try again. Okay, like this and like this. Okay, now it's bit better, I hope. And of course, this is the formula on how many combinations you have out of C and like number of combinations out of N and K. Yeah, N is the total number of elements, and the K is how many you want to choose out of this, and this is the number of and the combinations basically describe of how many unique ways you have of choosing those K elements out of the N. Yeah, so in this case we have that many paths, and we will want to choose N-1 or M-1 out of it. And that's equal. Where is the equal sign? Here. To that. Well, let's make it like this. And this is, of course, equal to what? Let's try to draw a fraction. Oops. Not like this. Like that. And here at the top goes n factorial. At the bottom goes k factorial times n minus k factorial. Yeah. That's it. And this is equal to something that we will be able to use in the code. We can basically leave the k the way it is, get rid of this, and rewrite it here in the following way. It will be n times n minus 1. I have to make it a bit smaller since it's too big at this point. Times n minus 1 times n minus 2 times n minus 3, and so on up until n minus k plus 1. And of course we can use a loop in order to compute that multiplication in Python. Yeah, but now there is something important. Is the important stuff is that n choose k is equal to n choose n minus k. Those are equal. Meaning that in our case, doesn't matter if we will, once we plug the numbers, whether we will do this and here n minus 1 or m minus 1. They will be equal. So now we can try to implement it, and n will be, of course, m plus n minus 2, as we said. A k will be minimum between n minus 1 and m minus 1. Why minimum? Because it will be less computation for us, and the result should be the same. And the result will store in a variable called result, which will return by the end. And now we will do some multiplications, mainly those multiplications here. Yeah, so for I in range starting from 1 till 1 plus k, we do result multiplied. Where's this? Sorry. Result multiplied by n minus k plus I divided by I. That's it. Let's try to run and submit. And it looks like we cannot do this since the division will be done before we multiply by n, or by the previous result, which will influence the final result. So let's try to do it in the following way. And the first two cases work, then the second case, and of course we are very fast. Now, so the second approach using dynamic programming will be a bit similar, but also very different. So we won't rely on any formulas, anything like this. We will store the previous results or all the results in a grid, of course, because it's a 2D problem, so we need to have a grid where for each row I and column J, we will store the number of ways to reach the following cell. So this is number of ways we can reach cell I/J, where I is the row and J is the column. And then how do we start filling this up? So first of all, dp on row 0, and for any column J will always be equal to 1, and same for any row I, but as long as we stay in the leftmost column, we also have all of this equal to 1. So we start here, and as long as we go just with the topmost row or the leftmost column, there is just one way. This is the number of ways, not the number of steps. It doesn't matter how many steps we go, as long as we non-divergent go, we cannot go up and down. That's why we have only one way. So as long as we stay there, there is only just one possibility, because we can only go to the right and to the bottom. And that's it. That's why I said that this is really important to understand, since it influences everything. And how to reach other places. So this is what we start with. And then we have recursive relation. Any other place we can reach in two ways. Either we went down, so we moved one step, and we cannot move down and to the right in the same step. So either we took this step, we just moved down, or there is a second option, we moved to the right. And those are the only two options, and that's it. That's the whole dynamic programming approach. So first of all, let me comment this out and create a new solution using dynamic programming approach. So first of all, we need to create our grid. We can call it dp, and that's the standard way, and we will fill it with this will be one row, which will have n zeros inside it, and we want to have n such rows. So in total, m rows and columns, and then we can fill the first, the topmost row and the leftmost column. So for I in range n, dp on index 0i will be equal to 1, and for j in range n, j0 will be equal to 1, and now for I in range again m, but we start from the first, since we have already filled the 0th column and the 0th row, and for j in range 1 to n, now we do our relation where we have dp on index I and j. Yeah, and either we went from the previous row or we came from the previous column. And that's it. These are all only two options, and now we can pick the last cell, which is on index m-1, n-1, and that is the cell that we are interested in. Let us run and see how it goes. And j out of range. And of course I swapped I and j, as I always do. Let me run. It's okay. And see how we do on all the test cases, and it's also very fast. Yeah. So in this particular case, it didn't really matter whether we use that approach or that approach, but I think that here for sure we use less memory. But either way, both, at least for those test cases, run in a very similar time, and both are optimal.